Right. So now let's briefly discuss this hypothesis test procedure. Again, we'll go into actual examples of this towards the end of the chapter, where then you will just actually see, again, what we had covered in Stat 130. So hypothesis tests are carried out by one, using a set level of significance, so alpha is pre-specified, as well as by assuming the null hypothesis is true. Okay, so that's always how we carry out a hypothesis test, no matter what hypothesis test procedure is being carried out. So then what we need to do is use the collected sample that we have obtained, obviously ensuring it is as representative of our population as possible. And then we try and prove that based on the evidence that the sample is giving us, that it is impossible for this null hypothesis to be true. Okay, so basically it means that then we have enough evidence based on our sample that we have obtained to prove that the null hypothesis is false and then must be rejected. Okay, so that's all we're trying to do. We're trying to collect this evidence to show that whatever the sample is telling us, it's definitely contradicting the null hypothesis. That means this null hypothesis cannot possibly be true, which means then we would reject it in favor of the alternative. And that's why the conclusion of a hypothesis test is always expressed in terms of the alternative. So when the null hypothesis is rejected, that means we have sufficient evidence to conclude that alternative. When it is not rejected, so when the null hypothesis is not rejected, we do not have enough evidence to conclude the alternative. But again, we do not accept the null hypothesis. You can't, just because you don't have enough evidence to prove that something is not false, it doesn't mean that it is true. Okay? So we're assuming it's true. And if just because we don't have enough evidence to prove that assumption of it being true is false, doesn't mean that it is true. Okay, so that's why how you express and interpret your results is very important. And it's also important if you eventually use stats maybe if you go into research one day, or if you at a company and you do some sort of study where you have to use statistics to analyze the results. It's very important that you know how to interpret the results accordingly, okay? Because obviously your interpretation of those results matters, because you are going to inform your boss of, based on the results, what they can do with this information. Okay, so something I did mention that when then the null hypothesis is rejected, it means that there is a significant finding, okay? And it's significant finding, it means that then that finding can lead to further implications, okay? Whether it be policies that are applied then, medical drugs that are released, or products or services that are then released by the company, something like that. Okay, so how is the actual hypothesis test decision made? So we know that for hypothesis test, we calculate a test statistic. And this test statistic is based on the information obtained from the sample. Okay, so whatever the population parameter of interest is, that then determines which test statistic formula is used. And then those values that are used in the test statistic calculation are based on the sample, as well as obviously the pre-specified value in the null hypothesis. Okay. The test statistic is then compared to a critical value. This critical value is obtained from our statistical tables and is based on our level of significance alpha, as well as the alternative hypothesis. So this is known as the critical value approach to a hypothesis test. So our critical value is just simply the cutoff value of our rejection region, okay? So our rejection region is a set of values such that the test statistic based on the test statistic, the null hypothesis would be rejected. And that rejection region depends on the alternative hypothesis. So this is just summarizing the test procedure and how the decision for this hypothesis test comes about. And this is just generalizing. Okay, we're not going to any specific types of tests that can be performed yet. But this is just summarizing your Stat 130 hypothesis tests that you have covered already as well. So the rejection rule for any hypothesis test is to reject the null hypothesis in favor of the alternative if our test statistic lies in the rejection region. And that means, and as discussed in the previous slide, the rejection region is dependent on the alternative. So we know for a left-tailed test, when is the null hypothesis rejected? Do you know the general rule of when the null hypothesis is rejected? What has to happen between the test statistic and critical value? Can anybody tell me?
Okay, if our test statistics lies on the rejection region, then we should reject the null hypothesis. But if it doesn't, then we do not reject the null hypothesis.
Yes, okay, that's true, that's correct, and that's the general rejection rule. But specifically for a left-tailed test, how do we know when our test statistic is lying in the rejection region? What about this test statistic?
It should be less than the specified value of population parameter.
Specifically the critical value. So you were on the right line.
Yes.
Thank you. So the null hypothesis is rejected if our calculated test statistic is less than the critical value. Okay? And that means it lies in the rejection region for this left-tailed test. And that's simply because we know for a left-tailed test, our rejection region lies to the left of the curve. So if the test statistic is very small, then it lies on the left side of the curve, which means it lies in the rejection region. So we reject the null hypothesis in favor of the alternative. Okay. However, for a right-tailed test, that means our rejection region would lie to the right side of the curve, which means we reject the null hypothesis for high values of the test statistic, because we're trying to prove that this population parameter is larger than this specified value of the parameter. So that means we reject for large values of the test statistic. So specifically for this right-tailed test, the null hypothesis is rejected if the test statistic is greater than that critical value. Because if it's greater than the critical value, it means it lies in that rejection region to the right of the curve. For the two-tailed test, we know that means we have two possibilities. So the null hypothesis is rejected if the test statistic is less than some lower critical value, so in other words, lies in the lower rejection region, or if it's greater than some upper critical value, which means it lies in the upper rejection region. So this is the general form of how we would perform this hypothesis test based on what we call the critical value approach. Okay, so we calculate this critical value from the statistical tables, whether it be the standard normal tables, t-tables, chi-square tables,